So welcome, everyone. So as Mark mentioned, I'm going to talk about usage metering, but actually it's going to be more about our journey, how we kind of spoilering, how we use Kafka and Clickhouse to collect usage data. But the beginning of the talk will be a little bit about what is even metering, why we are talking about, and just to kind of set up the context. Before we jump in, a little bit about myself. I am the CEO and co-founder of OpenMeter. Kind of the name tells it, we kind of do metering mainly for usage-based billing use cases. By the way, I was born in Hungary. I live in San Francisco. So this is really exciting to me to be back again and talk about the meetup here. So thank you for coming. My background is all observability, infrastructure, and efficiency. I was doing that at Netflix. I was working on the serverless infrastructure, mainly from observability and API angle. And most recently, I was at Stripe, where I was responsible for cost and all those kind of stuff. That was, by the way, giving the whole idea for metering. If you're interested about that story, please come to me, and I'm happy to chat about that. Yeah, you can find me on X, Twitter, whatever the new name for that platform is. I'm not super active these days, but I'm always receiving to direct messages. So let's jump in. What do you see here? Maybe this stuff looks different in Europe, but basically, I think everyone has some kind of memories. I mean, I know you are all hipsters driving Teslas these days, but try to remember last time when you went to the gas station, you see these numbers kind of rolling, probably, or especially in your high school years, like stomach was a little bit, I know it's pretty expensive here, kind of looking the numbers, maybe even try to stop it right, you know, the amount of money you had in your pocket. But basically what's happening here, what's great, that this is pretty real time, right? Like as you fill up your car, it's kind of the counter going, you see how much you pay. So that's why you can like really time it at the perfect amount what you have. On the other end, what it gives you, it's pretty accurate actually. So like I looked up for this talk, and what they do is like time to time, they bring this super accurate flow measurement device and they calibrate these. So it's real time, very accurate. And it also, you get a receipt at the end. And obviously there is some financial transactions. So it's very auditable. You can actually look how much you filled up, how much you paid. So pretty much that's how I like to define metering. It's kind of a combination of multiple things that maybe we are familiar from another aspect. Obviously, we are familiar with some kind of telemetry, observability, like a metrics when we want to measure maybe CPU usage, number of API requests. Telemetry data is real time. That's why it's great. If you have an incident, you want to see it immediately. You want to dig into that. So that needs a real time data. But on the other end, why metering is a little bit different, that when you have a telemetry data, it doesn't have to be 100% perfect. We have some sampling, maybe we are losing some events, that's completely fine, because we look only the bigger picture. That's not really acceptable with something auditable like metering. You don't want to double pay at the gas station, and the gas station doesn't want you to undercharge. So it obviously has to be more auditable, more accurate, no sampling. That's why metering systems are usually event-driven. So in that aspect, it's more closer for logging, although logging also kind of doesn't have that aspect that it has to be 100% all the data there. And the third aspect is the retention. So like this data is used in many cases for something billing related. So you need to be able to show that on a higher retention, and maybe some analytics teams want to look into how kind of the customer consumption changes. So that's how I like to define metering. It's real-time auditable, and it's need to retain for a long time. And that creates kind of new challenges. But before that, let's talk about kind of why metering is, again, kind of a big topic. Probably you all remember that when you were paying for your kind of phone subscription based on how many minutes you were talking. If we have Nokia folks in the room, I know it's called kind of like mediation, I think, in that industry. So metering is basically coming back for multiple reasons. There is usage-based billing is on the rise, which happening primarily for two reasons. One is the profit margins are shrinking in the industry, and usage-based pricing has this nice kind of capability that you can do cost-plus pricing, and you can give an organic account growth to the customer. So you don't have the sales team doesn't have to continuously go back and like, hey, you are using more, buy more. The customer kind of pays as much they are using, so they grow into the next kind of account tier. The other stuff which is related is the whole AI hype. And there is no talk these days without AI. We will have an awesome talk after this about AI, but basically all these LLMs and GPUs are pretty expensive. And that's why kind of one of the main driving factor, why companies both want to understand how much they are spending on these, but they also charge based on usage base because the cost plus pricing is kind of easier to handle the cost. And that's kind of another factor around cost, the whole FinOps movement, that companies kind of want to better understand what specific customers and product features use. So that's kind of the main factor why metering is becoming popular these days. And now the challenge is, I kind of mentioned, that now it's more from the angle when you need to implement metering, that we kind of discussed the accurate, the retention, and the real-time aspects, but the two other aspects that's only applicable more from the software engineering world is that it needs to be scalable. Like if you think about like a scale of OpenAI, obviously all the prompt messages generate some usage. You need to be able to collect data from infrastructure pieces, and it needs to be able to handle a big scale. And the other aspect why it's challenging, that while in the recent years we went through lots of standardization with tracing, metrics, logging, metering is not something that's standardized today. Lots of companies doing different things. My guess is in the next couple of years, it's going to be standardized and it's going to be part of some kind of these specifications. So now we define metering. The rest of the talk will be more basically what the title says, how we use Kafka and Clickhouse for metering, how we get there. OpenMeter is available on GitHub, so you can always look into kind of how it works. So I'm just giving you kind of the journey. So if you look at the GitHub repo, what you will find, there are kind of SDKs, collectors that collecting the data. It goes into an HTTP API, and then all the events goes into Kafka. If you're not familiar with Kafka, you can almost think about like this immutable log message queue, basically. And we do some deduplication. That's important because in distributed systems, you are going to retry events. And because it needs to be very accurate, you obviously want to filter them out. Then some aggregation happening, basically to get the final number. And it all goes into Clickhouse, the storage, which I spoiled in the title. But now let's jump back in time. So the first time when we started to look into metering, kind of Kafka was very early on part of the stack. We had this kind of huge influx of events coming in, and Kafka was really great to kind of handle the scale, have kind of this, the retention in the topic to kind of scale the processing. So Kafka was there from the very early days. But everything after Kafka was kind of part of an evolution, which in some sense even going on today. So the first part, to do the aggregations, part of the processing pipeline, we picked this technology called KCQLDB, which is like almost like a super simple version of Flink. I guess you can think about it that way. It's basically you can use SQL to describe stateful stream processing. It's really developer-friendly. It's really great, but unfortunately, it doesn't scale very well. Last time when I was saying this in a meetup, the KCQL creator was in the audience, so that was quite strange. But anyway, we went through. And then basically, all the aggregated events, so like we aggregate them in time windows that we sync into the Postgres database. And when I say aggregation, what we were doing, we were basically scaling down everything into tumbling windows. So like that way you can reduce the writes into this like Postgres or whatever database is at the end. You are not going to write for every single Kafka event. You are going to write it in a bigger chunks. In this case, it's every minute going to be one chunk. If you think about like in 1 minute, like lots of events can be kind of aggregated down and scaled down that way. So I mentioned that it's like super user kind of developer friendly, but one of the big problems around the scaling, KCQLDB was designed many years ago, and it's kind of not very it doesn't handle clusterization. You have to shard it manually. Basically, you have to run many different KCQL instances. You can't really move kind of Kafka topics in between. So it was just simply a very expensive and painful experience to scale the system that way. Also, there is really hard limits if you buy any managed KCQL DB, how many stateful operations you can run with. So we needed something kind of better, or something that fits more the use case. And that's when we find ClickHouse, which I'm going to talk in a second. ClickHouse is basically this columnar database that was built for analytical purposes, but it's like super powerful, and lots of companies started to use it even part of the product, like Cloudflare runs multiple products, Netflix running their entire logging stack on ClickHouse. But it's like limited in terms of feature set and what you can do. It doesn't really like mutations, for example. And for dedupe and batching, we needed to figure out something. And batching is an important part here, because although ClickHouse is really good handling in a large amount of data, it doesn't like very frequent writes. If you look up on Google like ClickHouse write frequency, one of the GitHub issue you will find from the Yandex days, it's a Yandex technology originally, someone mentions that ClickHouse likes 1 write per second, which these days it can handle much more, but it kind of gives you a sense that like how much batching you need to do. So you can just like grab your Kafka stream and kind of punch ClickHouse with that. So we needed something that kind of can do this kind of batching. And the other thing that's great, it has some built-in kind of engines that can handle, for example, aggregation. It has one for deduplication, but it has an eventual consistency. So we decided not to use that, because for a metering system, it would be really hard to explain to the user that you have temporary inconsistency in the number what you use, like your gas station number would basically fluctuate. So we decided not to use that, so we had to, that's why deduplication was on this side. But what ClickHouse was really giving us is basically this aggregated aggregation. It's actually so good and so powerful that we didn't have to use anymore any kind of stateful processing like KCQLDB, or Flink is really the big boy in this kind of stream processing world, which is not an easy technology to work with or operate. So it was really great that ClickHouse is powerful enough that we don't have to do the stream processing. We only have to deal with batching up the events, insert them in a big batch, but deduplicate them before. Couple of caveats that basically, like, yeah, we use the monetization views for that with that aggregation engine. I kind of put the slides early on, but monetization views are very different than in traditional database like Postgres. It's all happening at insert time. So basically, when you insert that huge batch in, that's going to move the monetization view. But the monetization view not going to follow any other changes after that. If you would change the underlying data, like you would delete a row, the monetization view not going to update. So it's basically a one-time update. That's what makes it really powerful, but that has another kind of problem, that if your monetization view goes out of the sync because you screw up your deduplication or eventual consistency or anything, then basically the only thing what you can do is you need to rebuild it. And rebuilding it is not easy. It's like it has a built-in command called populate. Don't ever use it. It's what it's going to do when it rebuilds it. It's going to insert the data as many times as many kind of replication you have. So in 3 replication, every data will be tripled. So really, the best way to rebuild is you reinsert every data, but that kind of means a bunch of kind of challenges around that. So now where we are, that we have this powerful kind of aggregation, but we need to kind of do the batching. So for the batching, the first thing what we did, we used Kafka Connect. Kafka Connect is basically, at this point, the standard way. It's a framework to bring in data and bring out data into Kafka. It's a very pluggable framework. It's basically every single database and solution has a plugin at this point, and ClickHouse had one, which was great at the beginning. So it does the batching for us, but now we run into other issues. It's very scalable. It does the batching. You can buy even manage Kafka Connect from something like Confluent. So it was really great from that point. But first of all, it was a very new connector. So we even had to kind of open pull request and do stuff. And we very quickly realized that when we want to do anything more advanced around data processing, even the deduplication, we would need to kind of modify the Kafka Connect, fork it. We wanted to do dead laddering. We wanted to do kind of a better separation between accounts. We wanted to do validation. We wanted to send the event into different place if it's invalid. And we suddenly reached the point when we were like, at this point, we are basically rebuilding the Kafka Connect. And we are not Java developers, and it was really challenging for us to operate and work with that. So we did what nobody should do. We basically re-implemented Kafka Connect, and we did it in Go. At least we know Go, or at least the others in the team know Go. So basically what we did in Go is we are running on Kubernetes. So we try to make a system that we can horizontally scale. It's very flexible to define which process consumes which partition, kind of gives that nice aspect. And that's very easy to do actually with Kafka, because the Kafka broker supports multiple strategies, which the Kafka clients also do. So you can pick a strategy that incremental reassignment. Actually, we don't really have time to go into them, but what's really nice, you get events when you subscribe to a topic or when you need to unsubscribe, and that way it's very easy to implement, actually. Easy is not the right word. It simplifies implementing it. So what it gave us, now we could move out the deduplication to different logic. Right now, we actually just do it with Redis. So basically, which is a great thing and not the great thing, that now that we have full control over when we take out an event from Kafka, how we validate it, how we deduplicate, and when we put it into ClickHouse. The problem with that one, obviously, now we own the whole eventual consistency problem, which is probably one of the hardest problems in software engineering. I know it's always caching and naming. I would put eventual consistency there. So we have to handle all of those on our own. And it's kind of means lots of testing, lots of edge case handling, but it's something that's manageable at the end. But what it really gives us is lots of control over this. We could even implement open telemetry tracing. So we have a full understanding how it works and how we can scale it. And yeah, I mentioned these Kafka handlers balancing for us, and we handled exactly once delivery on our own. So now we are kind of jumping to the learnings. So one of the biggest learning is ClickHouse is a really powerful technology. It can eliminate basically Flink and all this stream processing. I would definitely recommend to go with that instead of running a whole Flink cluster and trying to manage all these states. The other learning, ClickHouse prefers big batches. So now you own the batching. If you don't have an advanced use case, Kafka Connect can do it for you. So in that way, it's relatively easy. Kafka has a steep learning curve. It's an old technology. The information is still hard to find. We are still kind of looking into Liberty and all the details of Kafka, and it's kind of still an ongoing learning curve for us, but it's definitely not something that's straightforward immediately. And exactly one's guarantee, which I mentioned, that now you have to handle it, and it definitely requires some thinking and testing about it. That was the talk. I believe do we have time? Probably we have time. I'm always pretty fast talking. So if anyone has a question, then probably it's a good time. How much time do we have, Mark?
10 minutes.
OK, perfect.
And the pizza is not here yet, so please do ask questions.
OK, lots of questions.
OK. Thank you for the talk. I'm working for ClickHouse, actually. And,
Oh, really? It's a good thing I didn't say anything bad.
Correcting the mistakes he made.
Yeah, so I'm just curious if you considered using cloud version of ClickHouse, because cloud version has some integrations already implemented, like for Confluence Cloud, for Confluence, other things.
Yep. The question is if we considered using ClickHouse Cloud because it has integrations with Kafka, especially with Confluent. Yes, we actually use ClickHouse Cloud. And I know you guys has a ClickPipe. But when we started it, ClickPipe was in the very early days. And we still can't implement the custom validation logic with that. That was kind of, that's why we use ClickHouse Cloud. But we don't use the the helpers to bring in data. But the Kafka Connect plugin we use was also an official ClickHouse Kafka Connect plugin.
Do you manage Kafka yourself?
No, we use Confluent actually, and ClickHouse Cloud. So we just really own the kind of the glue between them.
Cool, thank you.
One question there?
Very familiar shoes now. I think like very similar to what you were doing. Do you suggest me to go hire Go developers now? Or what's my kind of go-to strategy? Because like, this is kind of what we were considering before, right? But now listening to this talk, it's
You mean you were considering the Kafka Connect with the...
Exactly that.
Honestly, if you don't have a special logic, the question was like, so they are considering to build something similar. I'm just repeating for the call, and if I would recommend still to go with Kafka Connect. Honestly, I would absolutely recommend if you don't have a special logic, you need to put in that processing pipeline, like for us, the deduplication and the validation, then I would use Kafka Connect. Like that does a great job with the batching, and then you don't have to worry about it. For example, the ClickHouse Kafka Connect plugin, how they do the deduplication, they actually almost do the same what we do, but they use the ClickHouse built-in it's a key value store in ClickHouse, which it doesn't click the name. Maybe you know it. Okay. If you go into the Kafka Connect ClickHouse GitHub repo, you will find in the documentation their architecture and how they implement it. We basically re-implemented that part of our processing. Question there?
Yeah. How do you handle errors in your Go consumers? Because do you handle it like database transactions? Because losing like metering events sounds pretty troublesome.
So what we do is we basically, so part of the stream processing, we try to pause the event against the meters. It's basically in OpenMeter works in a way that one event can move multiple meters. The very typical use case, like if you build a serverless application, maybe you want to report kind of how long the request was running, how much network it was using, storage, blah, 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 in one event. So basically, we try to match all your meters on it, try to pause the data. It's basically a JSON kind of blob. And if it doesn't match to any meter, or we can't pause it, or the type is invalid, then we basically put it in a separate, no, in the same table actually, but we mark it with the error. We put the error, and on the UI, you can actually look it. So like that way, you have some kind of visibility that I had an error, which I'm not handling. So we're not dropping it basically, but it's also not moving the meter, obviously.
You discussed pretty much about the ingestion of the data, but what happens after you ingested the data? Do you have any data processing applications to get the data, gain the main knowledge and present it to the customers, or you're just focusing on the reprocessing?
So basically, in a ClickHouse, the data is sitting in these 1 minute chunks. So it's pretty quick to query it, because ClickHouse works in a way it basically scans through the rows, and it significantly reduces the number of rows what it scans. So for the use cases what we have, we just read the data from the database. I intentionally not talking about the use cases because I know it's part of the code of conduct not to promote the product. But after the talk, I'm happy to share the specific use cases.
One question. Do you use event timestamps or ingestion timestamps?
Very good question. We right now use event timestamps, and we are about to add so we use event timestamps, and we are about to add ingestion timestamps because it's kind of challenging now.
One more question. How do you handle late events?
Late events. It's actually late event works because ClickHouse doesn't really care about it. It's going to write it in another partition. So if lots of late event arrives, it's not great because you will write multiple partitions. But the multi-set view going to work. Right now, we don't do any enforcement to kind of not let you. Where it really matters is the deduplication for us, because we do a 32 days historical deduplication. So if you send data which is older than that, then obviously that's not going to be deduplicated anymore. Okay, one more.
So you use Go for this for your part. Is it so Go has a nice performance, and I also like it. But do you consider, I don't know, going down with a bit more performance language, or you had more I/O binds programs, so you don't have to go down for, I don't know, Rust or C++ or something like that?
Yeah. So with the current scale, we don't really started to optimize kind of that layer of the stack. We are happy with kind of the horizontal scaling. Obviously, it's worth calling out here that you can only scale to as many topics you have. In Kafka, it's always basically the Kafka topic is the, partition. So, okay, now we have to go into basically Kafka topology for people who are not familiar. So basically in Kafka, you have topics, which you can almost think about like your message queue. But one topic is backed by one or many partitions. And basically the partition is kind of one Go process, one client is basically reading only from one partition. So that's the lowest number you can go. And in Kafka, it's somehow challenging to merge topics, but it's relatively easy to split topics. So they can always just split it, and put more processes in. But yeah, I agree. One day it's probably going to be a problem, and we will look into, I don't know, Rust or what's the cool stuff these days, and then we will optimize it more. Probably one final question, or if there is no questions, then thank you very much.